The Spread of the Data R tutorial. In the Spread of the Data lecture, we saw Jeff introduce 3 different methods that can describe the spread of the data. Let's see how we can use R to help us understand these methods better. To get started, we will read in the life expectancy dataset and name the second column with the actual life expectancies life EXP. We are now ready to work with this variable. Jeff began with a box plot of the data. We can reproduce this box plot with the Y limit set from 40 to 90 to get a closer look at the data. And to follow along with his lecture, we can produce the summary statistics as well. The first measure of spread we learned was the range, and we can see from the summary statistics, as well as from using the range command, that the data ranges from 47.8 to 83.4. We can do a simple subtraction of the minimum life expectancy from the maximum life expectancy to obtain the range of 35.6. The second measure of spread we learned was the inner quartile range, or IQR, which was the difference between the third quartile and the first quartile. We can do this directly with the IQR command to obtain an IQR of 12. For the next measures of spread, the variance and standard deviation, we will work with the 9 grades dataset from Jeff's seminar class. When calculating the measures of spread, it is useful to have the summary statistics to be able to calculate the range and IQR. For the variance of the grades, we can use the command VAR to obtain 87.3, and for the standard deviation, we can use the command SD to obtain 9.3. Note that the standard deviation can also be obtained by taking the square root of the variance. Sometimes it is helpful to carry more decimal places, but you might have noticed that all of Jeff's answers are rounded to 1 decimal place. We can of course do this in R as well with the round command, specifying that we would like to keep 1 decimal place. In Jeff's final example, he considers again the salaries of the New York Red Bulls and tries to assess the robustness of the new measures learned by comparing the measures for the original data and for the 8% trim data. We know that the 8% trim data would require us to remove the first 2 and the last 2 observations. Let's load the data in R and produce the trim data. We will call this trim data NY salaries trim. We will first set it equal to the sorted salaries, then we will specify that we wish to keep every observation from the 3rd to the 23rd in square brackets. Just to double check, we know that we started with 25 observations, so the trim data should contain 21 observations. First, we will produce the summary statistics for the original salaries, storing them each with appropriate variable names. We will combine them all under one variable, origin. Similarly, we can do this for the trim data, making sure to indicate in the variable names that the statistics produced refer to the trim data. We can now combine them into 2 columns with the command cbind, so they are easy to view side by side, and we'll rename the rows for reference. This allows us to see all of the summary statistics produced over the last few lectures and compare them easily to see which are robust to extreme observations. Do note that in the lecture video, Jeff uses approximated statistics, whereas we use the actual calculated statistics. Either way, the lesson remains the same. The median and IQR are robust, but the mean, range, and standard deviation are not.